Hello chemistry students, this is the video key for valence electrons and electron dot structures. At the very beginning you have a really important statement that you need to be able to fill in the blanks for. Atoms are neutral, they have no charge. And remember that this is because they have equal numbers of two oppositely charged particles, protons and electrons. So sometimes, though, which we'll find out later on, atoms can lose or gain electrons. And the number of electrons that are gained or lost depends on the number of valence electrons. So anyway, this is our periodic table, and you'll notice that here we have group numbers that are identified. So all of the elements that are in group 1A have one valence electron. All of the elements that are in group 2A have two valence electrons. Remember that we skip the middle. And then 3A, 4A, 5, 6, 7, 8. Remember that the only one that is the exception to this rule is helium, which only has two valence electrons. So we can use our periodic table to answer these questions here. So how many valence electrons are there in these atoms? Well, we have lithium here, which is in the first column, so it has one. Carbon is in the fourth. Helium, I explained, is the exception. It only has two valence electrons, and the reason why is explained in a previous video. And then hydrogen is again in the first column here, so it's only got one. And then bromine is all the way in the seventh, so it has seven. So how can you use the periodic table to determine the number of valence electrons? Number the columns, skip the middle. The column number tells you the number of valence electrons. All right, next we needed to draw Bohr models for these elements. I'm going to draw these, but let's do beryllium first. So beryllium has 4 protons. And that means that it has 4 electrons. But beryllium is in column number 2. So 2 of those electrons are valence electrons, and the directions say to use X's for the valence electrons. So that's what I'm going to do. So there's beryllium. Now if I wanted to take that last electron and put it off to either this side or this side, either way is fine. It just can't be right next to each other. Fluorine has 9 protons and 9 electrons total, but 7 of those electrons, and I know that there's 7 because fluorine is here in group 7, 7 of them are going to be valence electrons. And then finally we have argon, and there is your Bohr model for argon. So if we were going to draw electron dot diagrams or electron dot structures for these Bohr models, the dots would only reflect the green X's. So let's take a look at our next page. You guys should have read all of this already. It gives you a step-by-step on how to draw them. But let's take a look here at argon. So argon has 8 valence electrons. So if we look back at our drawing here, there are 8 different X's that we have. So our electron dot structure for argon is only going to have 8 dots. Even though argon has 18 valence electrons, it has only 8 dots. All right, let's start over here at the beginning. Here we have chlorine. Chlorine is in group number 7. And so chlorine has 7 dots. Helium is in group 8, but remember that helium only has 2 electrons, so it can't have 8. So we're going to draw helium's 2 valence electrons like so. Could I have drawn them like this? Yes. Could I have drawn them like this? Yes. Could I have drawn them like this? No, that would have been wrong. So for helium, you're going to have 2 valence electrons, but, sorry, I'll make that one pink. 2 valence electrons, but they have to be separate from each other. Sodium is in the first column, and so sodium would have 1 valence electron. Silicon is in column 4, right below carbon. So we have 4 valence electrons. Beryllium, we drew the Bohr model for beryllium. 2 of those electrons are in the inner shell, 2 of them are in the outermost shell, so we're only going to draw the 2 that are in that valence shell. Lithium is in column 1, so it has 1 valence electron. Phosphorus is in column 5, so I'm going to draw its 5 valence electrons. And again, for phosphorus, notice how the pattern that I used in order to draw them. Like, I could tell if somebody didn't follow. You know, if you end up with phosphorus looking like this, I know right away that you didn't go top side, bottom side in order to draw those out. So make sure that you're following that pattern. It's going to be very important later on when we do some bonding. Arsenic. Oh, I forgot which column arsenic is in. Let's go back up and look. So arsenic is here. Oh, right below phosphorus. So it also has 5 valence electrons. So we have 1, 2, 3, 4, 5. Iodine is in group 7. Aluminum is in group 3. Rubidium is in group 1. Carbon is in group 4. Boron is in group 3. Selenium is in group 6. 1, 2, 3, 4, 5, and 6. And then fluorine is in group 7. And so there you are. That's how you draw electron dot structures.